The design philosophy was to make a reliable system, to make it lightweight, and to build an amount of redundancy in the system. And as you can see on the graphics, you have two sets of solar cells, namely the X plus and minus, the Y plus and minus, and the Z plus and minus, basically operating in pairs. And you'll see that one pair is always highly illuminated versus the others are not so illuminated, and it alternates. So conventional battery chargers, according to my understanding, basically fed all the solar cell panels with diodes into a battery charger, and that was it. Now, I thought that's not a very efficient way of doing it. Only the cell with the highest potential basically can supply the power. So I thought, well, if I make 3 chargers, each fed from a particular axis cell couple, then we have redundancy, and we also have, I think, more power out of this whole system. And so that's what this basically is. We have 3 individual battery chargers, which basically look at the 3 individual solar cell pairs, and they operate in parallel, independently, and each battery charger then has the capability of supplying its maximum power as a pair of solar cells into this. This also creates reliability, because if one solar cell or the battery charger associated with that solar cell set fails, you have still 2 left to operate from. The original prototype, we used power converters running at about 50 kilohertz. That was 10 years ago the sort of norm. Now we're running at half a megahertz, or even 1.5 megahertz. So because we were able to increase the frequency by a factor of 10, the components were much smaller. The magnetics are actually quite small, and specifically the problems with capacitors were reduced, because you can't get tantalum or electrolytic capacitors for space grade easily. So we're using very high quality ceramic capacitors. Okay, so everything becomes smaller and far more efficient. We're using, in this particular power conversion system, you need a converter which can operate below and above the battery voltage. And so we're using here a particular converter type topology, which is very popular these days, which allows us to do that. And it's got some very interesting advantages, namely that the battery is totally isolated from the power switch. Normally, if anything fails in a battery charger, it's the power switch. So, and what happens then? You drain your battery via your power switch. And so that problem is also eliminated. Also, because the battery is totally isolated from the power switch, there's no leakage. It's a safe way of doing it. And the other thing which is very important is that the battery can be grounded. Okay, so it's a very tidy topology. The rest is actually very straightforward. We use modern components. The battery bus is controlled, and after the battery bus we basically have two power converters supplying 12 volts and 5 volts, both tightly regulated. Apart from that, we have two A2Ds with some decoding logic supplying the currents and voltages of all 6 cells. We measure the battery voltage, the battery charge current, the temperature via an NTC resistor, and we measure the regulated 12 and 5 volts voltages and currents, I think. And that's about it.
So here on the PC we're running some software that is a graphical simulation of KiwiSat, and the PC program is sending serial commands to a microcontroller in this box here, and the microcontroller interprets the serial commands which represent the current levels coming out of the solar cells, and drives some current generators which then pass the current through to the BCR. And the whole purpose of this is to simulate the solar cells to the BCR so that we can exercise the BCR on the ground here. So this simulation here at the moment just has the satellite by itself, but in the future I'm hoping to add the Earth in the background as well to make it a bit more graphically exciting. And on the meters here, when the thing is running, it's just switched off at the moment, but when it's running we'll see the meters changing based on what current the generators are producing to the BCR at any point in time.